Antarctica is the coldest, most unforgiving environment on Earth. Yet rising straight out of this frozen wasteland is a massive, active volcano that spends every single day raining a literal fortune in gold onto the surrounding ice. This is Mount Erebus. Towering more than 12,400 feet above the Ross Sea, it holds the title of the southmost active volcano on the planet. Deep inside that crater, Erebus is busy churning out approximately 80 grams of pure gold every 24 hours. Over the course of a year, that adds up to roughly $2.1 million worth of the precious metal scattered into the freezing air. While the financial value is significant, the mountain's chemical behavior is what separates it from every other peak on Earth. It is successfully performing an act of alchemy found nowhere else, solidifying precious metal directly from a cloud of gas. When you look at other highly active volcanoes like Kilauea in Hawaii or Mount Etna in Italy, finding trace amounts of vaporized gold mixed into their hot gas emissions is a normal part of the geological process. Mount Erebus operates on a different set of rules. It is the only known volcano on Earth where that metallic vapor manages to transition into perfectly organized, solid microcrystals of pure gold. Every other active plume on the planet leaves that gold in a gaseous state. Finding the specific mechanism that turns this particular volcanic vent into a source of solid crystals requires looking closer at the environment at the edge of the crater. The process begins deep within the Earth's crust. As magma rises toward the surface, it heats up to around 1,000 degrees Celsius, vaporizing a cocktail of trapped minerals. This includes chlorine, sulfur, and trace amounts of elemental gold. To get that vapor to the surface, Erebus relies on a rare delivery mechanism. It contains a permanent, exposed lava lake, a feature shared by only a handful of volcanoes worldwide, which has been continuously churning since at least 1972. Most volcanoes build up pressure and explode violently. Erebus breathes. Its persistent lava lake acts like an open window, allowing hot, gold-rich gases to bubble up steadily and escape into the atmosphere. This slow, continuous off-gassing provides the unusually calm volcanic environment required for delicate molecular structures to survive the turbulent journey from the deep crust to the open air. Once that gas hits the surface, it encounters a severe thermodynamic clash. You have a volcanic plume sitting at 1,000 degrees Celsius colliding instantly with Antarctic air that can drop down to minus 50 degrees. Volcanologists have two leading hypotheses for what happens next. The first suggests that the extreme temperature shock causes the gold vapor hitting the freezing air to instantly separate, condense, and freeze into microscopic geometric crystals. The competing theory argues that the gold slowly crystallizes directly on the cooling liquid crust of the lava lake itself. Then, as gas bubbles rise and burst through that crust, they sweep the pre-formed crystals up into the air. Whichever mechanism is responsible, the resulting particles are incredibly small. These gold crystals measure anywhere from 20 to 60 micrometers across, making them thinner than a single strand of human hair. Because they are so light, these microscopic specks are easily caught in the rising volcanic plume. From there, they ride the severe Antarctic winds, drifting and settling on the ice up to 1,000 kilometers away from the crater. Whether forming mid-air or popping off the lava crust, the end result is a continuous, invisible gold rush scattered across a completely frozen continent. With $2.1 million worth of gold falling from the sky every year, you might naturally wonder if someone could set up camp and collect it. The physical reality makes that impossible. This isn't a concentrated vein of ore. It is microscopic dust dispersed incredibly thin across thousands of miles of deadly, unpredictable, and shifting glacial terrain. Even if you could design a vacuum large enough to sweep the continent, international law stands in the way. The Antarctic Treaty strictly prohibits any activity related to mineral resource extraction, reserving the entire landmass exclusively for scientific research. Because the gold is physically uncollectible and legally untouchable, scientists don't measure its worth in dollars. They measure it in data. Researchers use these gold crystals as geochemical tracers. By studying them, volcanologists can map the hidden plumbing of Erebus and better understand exactly how heavy metals move through the Earth's deep interior. That same continuous heat and gas release produces another incredible byproduct. The steam creates towering ice fumaroles on the surface and hollows out sprawling, interconnected ice caves around the summit. The environment inside these caves is bizarre. They are pitch black, starved of organic material, and can reach warm temperatures of up to 25 degrees Celsius. Yet, despite these harsh conditions, they host thriving communities of undiscovered microbes. This makes Erebus a massive point of interest for astrobiologists. These extreme, isolated caves serve as a natural analog for studying how life might survive under the ice of other frozen worlds. Mount Erebus functions as a vital, living laboratory. Between the rain of gold and the isolated cave ecosystems, it offers a rare vantage point into the inner workings of our planet and the survival of life across the cosmos.